Hello and welcome back to Dr. Logic Awkwardly Does Logic. Today I want to talk about the proof system that we've been developing so far. We've got the basic rules, we've got the derived rules. I could probably teach you more derived rules because there's various other shortcuts that you can take. I mean, any time that you can recognize a pattern that shows up in proofs over and over, you can turn it into a derived rule. But there is a point of diminishing returns after which it doesn't really make any sense. The proofs are still going to be kind of simple enough with the ones that we've got. So I'm not going to do that anymore. Instead, I want to talk about why we pick the rules that we pick. A lot of times when I've introduced a rule to you, I've made reference to the truth tables and I've said things like, well, if a conditional is true and one of the antecedent is true, then the consequent has to be true. Or think about disjunctive syllogism. If you have a disjunction, then you know at least one of the disjuncts has to be true if the entire disjunction is true. And if you know that one of them is false, well, then the other one has to be true. So we have cited reasons of it. We've talked about truth as motivation for the various rules that we have. But just a moment, naughty cat. Hey, stop that. But the rules themselves don't actually say anything about truth. They are purely syntactic. They look at the structure of the sentences and what has already been written down in a proof and allow you to write down more sentences. Now, what we're going to be talking about next is actually linking together the proof theory and the semantics in a very intimate and close relationship beyond just kind of using them as this sort of, justification, intuitive reasoning for why we picked the rules that we picked. The reason we've picked the rules that we have is because they are sound. Now, this is a technical term in logic, and what it means to say that a system of proof or proof rules is sound with respect to some set of semantics. So in our case, propositional logic truth tables is just to say that the rules are truth preserving. That if you start off with things that are true, the rules that we have defined will never allow us to derive something that is false. So it's a hypothetical notion of truth in that we say, assume that our starting point is true. So assume your premises are true. Then our rules of proof will allow us to derive only true things. So if you think back to when we were talking about other semantic notions, such as the validity of arguments, then what we are doing is showing that our proof system can only prove valid arguments. Now, we're not necessarily saying that the arguments are sound, because remember the notion of the definition of soundness with respect to an argument is that the argument is valid and the premises are true. Now, we're not saying that. The notion of soundness that we have of a proof system with respect to semantics just is this hypothetical notion of if the premises are in fact true, then everything that we derive from them will be true. So how do we go about proving that? Well, we've got to do it for each one of the rules. The bookkeeping rules are the most straightforward. Assumptions are true by assumption. So if we are assuming that our assumptions are true, then our assumptions are true. I mean, this is basically a tautology. The bookkeeping rules are also straightforward. So if we assume that kind of everything that we've written down in our proof so far is true, and then we reiterate one of those lines, it's still going to be true, because writing it down again doesn't change its truth value. The other rules are somewhat more complex, of course. The introduction and elimination rules were designed to match the truth tables, and so we will have to go through each of them and demonstrate how it is that they match the truth tables and how we can go from the assumption that if everything in the proof so far has all been a legitimate move, then what we derive using the application of a particular rule will itself also be true. Now, in these videos, I'm not going to go through every single rule. I'm going to give a couple examples of how you would prove the soundness of rules and then leave the rest of this exercises to you. Because, I've got to test my students on something, so I can't give away all the answers here. But this is the general idea of what we're going to be working on. There will be a couple of kind of interim stages that we go before we start looking at the soundness of individual rules, because there are a number of kind of facts about proofs and the way that you can kind of move from one type of proof to another type and vice versa, which can be super useful. In fact, what I'm going to be talking about in my next video is actually like the first stages, the first steps into an entire branch of logic, which is called proof theory, which is all about what you can prove, how you can prove it, questions of what's the shortest proof, or can you show that none of the steps in a particular proof are redundant, that you couldn't have done it without them. Proof theory is, as I said, it's you could go on and do graduate studies in proof theory. You could devote an entire research career to proof theory. What we are doing in this series of videos at this point is really just the very first little steps into it. But I hope you find it interesting and also get a sense of kind of what's going on beyond just manipulating symbols and going from certain premises to certain other premises. I want you to have a chance to see why we have the rules that we have and the ways in which proofs work at a very deep and sort of structural level. So that's what we've got coming up in the next couple of videos. I'm going to talk about the deduction theorem. I'm going to prove the soundness for various rules. I will give a couple of pointers for the other ones, but I'll leave those as exercises for you. And that will actually bring us soon to wrapping up what we'll be doing with propositional logic, at least at this point in the series of videos. There are other cool things about propositional logic that I will kind of wave my hands at. I won't actually prove at this point, but hopefully someday, maybe around like video 200 or something, I'll get to those. We'll see. Anyway, thank you for joining me, and I look forward to seeing you again. Cheers. Bye.